Okay, today's experiment is the heat of neutralization. And what you're going to do is react an acid with a base, and the product will be salt and water, and that's considered neutralization. So if you were to get an acid on your skin, you'd put a base on it to neutralize it, and vice versa. So what we're going to do is we're going to take out pre-measured 2 molar HCl, pre-measured 2 molar sodium hydroxide, mix them, and monitor the temperature, probably about 15-20 minutes. Take the temperature every minute. And once we get the data, we can plot our data, get a delta T so we can plug it into this formula and determine the energy involved. M, of course, is mass. The specific heat will be water, since our solutions are made in water. So this is the foundation of this experiment. We are going to determine this number. We know experimentally what it should be, and hopefully we can come in with close range to that. So again, if someone talks about neutralization, it's the reaction between an acid and a base producing salt and water. Okay, so what we're going to do is we're going to take an acid and a base, monitor their temperature for 5 minutes, each one independent, in different styrofoam cups. Then we will mix them together and monitor the temperature change until we get a significant decrease in temperature. So then we'll plot our data, you put in a best fit line, and this, between these 2 points, is my delta T, my temperature change, so I can use that in that equation to determine the energy involved. So we have to plot the data, and I will plot the chart for you, but I will get the data for you also. So I'm going to mix together those two things. This is our setup. Here we have the base in the yellow. The red is the acid. Notice we have two thermometers, one for the acid, one for the base, because we're going to monitor their temperature for 5 minutes. Then we're going to mix them. So that should give you sort of an idea of the setup. Of course, taking the temperature every minute for 5 minutes is not going to be very exciting, so we may delete that part. So I'm going to put my acid in the acid container. Now the reason I'm using styrofoam cups is to minimize heat loss. So each has 50 mils or 50 grams. Remember, we're using the density of water as our reference. So I'll put a little cap on. This is sort of to prevent any energy loss. Design the thermometer so I can read it. And this is to minimize energy loss. So for over the next 5 minutes, I'll read the temperatures of the two and record those. Okay, it's coming up on 5 minutes, so I'm going to make my last reading. After I've made my last reading, then I will mix either the acid and the base, or the base and the acid, and then continue reading for another at least, probably another 15 minutes. Okay, so now I will mix them. And it doesn't matter which one I add to which one. Okay, so I'm going to put the acid in the base. Mix them a little bit. Wait a minute and make a reading. And again, I'll make these readings for approximately 15 minutes and note the temperature change. you look at the data, this is the temperature of my acids, this is the temperature of my base over 5 minutes. I mixed them together and it jumped up to 36, peaked at about 36.6, and then progressively, slowly went down. Okay, so now I need to plot this data so I can calculate my delta T, because I need a delta T, because remember, this is what we're going to do. We're going to take our experimental data, put it in time versus temperature, and plot it, and then we can get our delta T to use in our calculation. So I will plot that for you, and then there will be a post of that for you to make the interpretation. Now, of course, because I mixed acid and base together, you know your products are salt and water, so salt and water can be thrown down the drain. So I haven't created any nasty waste products with the experiment. I just have to dump my salt water down the drain.